Good evening, everyone. My name is Daksh Gupta, and I'm a third year undergraduate student at the Department of Aerospace Engineering. For the Project of Innovation Lab course, I have made a thrust stand which will measure the thrust of any medium sized or small propulsion system using this thing. It is the main measuring unit in the thrust stand is the load cell. The load cell is a strain gauge based measurement system which comprises of four quarter bridge strain gauges. The bending of the load cell uh, is measured through deflections in the through is measured through strains in the strain gauges, and those strain gauges convert the strains to electrical signals which will be transmitted and then can be uh, used to find the force on the load cell, and hence we can find the thrust. Now load cells are usually made for making weighing scales and measuring weights in the downward direction, but we can also use them in a vertical alignment where we can also get the thrust of any propulsion system like a drone motor or a small propulsion system like an ion thruster. For the current project, I could not access a drone motor or any small propulsion system. So in this project, I have just calibrated it to some extent with using a known weight of 1 kg. This load cell particularly can handle 20 kgs of load and can is precise up to 20 kilos. The load cell circuitry is shown in the figure here, where there are four strain gauges in the load cell. So each of the strain gauges will give four electrical pulses. E plus and E minus are conventionally called the powering lines, and A plus and A minus are usually conventionally called the measuring lines, and they are connected to the amplifier, the HX 711 amplifier, which amplifies the signals of the load cell, because the load cell has a signal strength which is very small and cannot be directly used for measurement. So we connect it to the amplifier, which is conventionally powered by an Arduino Uno, but in our case, we are using an ESP32 for powering our circuit. ESP32 is very similar to Arduino Uno as a microcontroller. So the circuitry is the same for both Arduino Uno and ESP32. The amplifier pins are connected as similarly. The voltage is powered by V in and ground, and the D out and SCK pins are connected to the digital input pins of D4 and D5 of the ESP32. The code for ESP32 is written in Arduino IDE, and the code here is as follows. The library for this code used is HX711 underscore ADC, which was available in a GitHub repository, and this is the code for calibration and measurement of the load cell readings. The code is quite simple, and it uses the inputs from D out and SCK pins to make the object load cell, and based on this object load cell, it defines the calibration parameters. Initially, we will tear the load cell to zero value, and with a known weight of 1000 grams, we will set the electrical signal value for 1000 grams as some fixed value, and as the deflections and bending are for the load cell are happening in the elastic region, the forces will be proportional to displacements linearly, and hence for any other unknown weight, a linear interpolation can easily be used to find the force. So we will begin with the calibration process right now, and in In the calibration process, the first step is to tear it. For the tearing part, on the Arduino IDE in the serial monitor, we just have to type T, and it has taken the mass of the load cell as 0. Now, coming to the part where known weight will be measured, we'll be using this pulley type configuration to use this weight as a thrust transformation. There are a lot of unknown variables in this calibration process which we cannot currently identify with a very good accuracy. So for now we'll assume these parameters to be known to some value, and we'll say that the force on this load cell currently is equal to the weight of this bottle right now. And when this bottle is let free on the load cell is deflected in a cantilever fashion, and the reading has been given as 1000 grams because this load cell gives an output in terms of the load cell gives the readings in terms of grams because the load cells are usually made for measuring mass and not weight. So any thrust we measure will be in terms of mass from this particular system, and this is how the calibration process is done. To measure any known weights, we don't have any other known weights right now and no other propulsion system that we can directly use to measure the thrust of. Thank you for listening to this presentation.